This is Christian Sawyer with Tectonicus Constructs, and we're developing the Solar River project, which seeks to cover and power canals with solar energy. Canal-spanning solar projects, or CSSPs, address many of the major problems at the water energy nexus. Moving water is the largest single user of electricity in the western United States, and thermoelectric power generation is the largest consumer of water. CSSPs consume 65% less water than thermoelectric power and can reduce 67% of water evaporation, saving more than 1 trillion gallons of water in California and Arizona annually. A 1,200-year drought has led to Colorado River water cutbacks, increased dependency on limited groundwater supplies, the federal government paying farmers not to farm, and lake power reaching historic lows, now only 25 feet away from the generators shutting down. This shortage is also expected to drive up the cost of thermoelectric energy, making lower water consumption sources of energy, like CSSPs, more competitive. CSSPs also reduce maintenance costs by preventing algae blooms, sedimentation, and water hardening. In 2021, over 15,000 megawatts of land-based solar projects were rejected due to their impact on natural habitat, landscape beauty, sacred sites, and existing land use. Canal solar is also expected to improve upon typical photovoltaic efficiency due to cooler microclimates created between the panels and canal waters. CSSPs can provide revenue to irrigation communities for upgrading the water efficiency of their irrigation infrastructure, while also enabling the transition to electric water pumps and farming equipment. Importantly, CSSPs could help bring power to the 14% of Native American rural communities who currently have no access to power. In Arizona, at scale, CSSPs could generate 23% of the state's electricity needs, save 23 billion gallons of water annually, reduce carbon emissions by 9%, and avoid bulldozing 140,000 acres of land for solar. To optimize the design of CSSPs, we've created a parametric software solution which adapts to environmental and budgeting specifications. Machine learning is used to iteratively optimize designs for the lowest levelized cost of energy. Generated designs can be used for preliminary studies, feasibility studies, and construction documents. Our software solution now includes a free web-based interface. Users can navigate an interactive map and trace the canal lines where they'd like to model a CSSP. Our app will generate estimates for energy production, water savings, land savings, carbon emission offsets, costs, and LCOE. This free tool can save interested developers up to $50,000 in feasibility studies and initial engineering fees, eliminating a massive financial barrier for underserved communities. This generated data can be used to apply for grants and loans. Our parametric script calculates solar resource, weather data, structural loads, wind loads, wiring and inverter selection, voltage and string logic, pricing, and optimal LCOE. On the hardware side, we worked with canal engineers to design an adaptable structure with modular parts and a consistent fabrication method which is uncomplicated and safe to build over moving water. Each module can be lifted or removed for routine maintenance or emergencies. In the Southwest, there are over 150 irrigation districts and over 10,000 miles of canal which could be covered by CSSPs. As water scarcity increases and the demand for renewable energy continues to rise, we expect that low water consumption energy sources like CSSPs will compete with or even outcompete energy sources such as nuclear and natural gas in many areas. The projected market of prime canals is $325 million and growing. Our 3-tiered software solution includes the free web-based app for onboarding new clients, generation of CSSP designs, and full-service engineering assistance from preliminary studies to commercial operation date. Since receiving our READY award, we've hired 3 additional staff members, landed our first commercial client, the Gila River Indian Community, improved our software to generate designs up to 20 times faster, and translated our code for web app integration. With SET funding, we will increase the predictive accuracy of our web app, create a standalone software product, integrate cloud-based processing, provide the ability to generate models for curved canals, integrate grid connection costs, and optimize the logic for advanced wiring and automated inverter design. We've established several JEDI milestones for Solar River. The first is to launch our free web app and invite disadvantaged communities to assess their canal's potential for CSSP development. The next is to power Gila River's entire water system with CSSPs and eventually facilitate their transition to total tribal energy sovereignty. We'd soon like to see CSSPs bring electricity to non-electrified rural and tribal communities and enable the transition away from diesel equipment and pumps, which deeply impact the well-being of rural communities due to sound and air pollution.